Today I'm going to talk about logistic regression review. It is part of the course Spark and Python for Big Data with PySpark. Logistic regression. What do we, in this part, we'll delve into three main topics. Why do we need logistic regression? Classification problems. Logistic regression to solve classification problems. Now let's dig deeper into why do we need logistic regression. In real life, not all levels are continuous. Sometimes level can be in terms of categories as well. And when we need to predict categories, this kind of problem is called classification problem. Logistic regression is one of the basic way of tackling classification problems. Now let's talk about classification problems. What are examples of classification problems? Examples such as spam versus ham, classifying emails, whether it is spam or whether it is a ham. Ham means a good email. That's an example of classification problem. Another problem is classifying or predicting whether a customer will default in a loan, yes or no. Thirdly, is about diagnosing a disease, meaning based upon evidence, we have to say that whether a person has a certain disease or no. These are all examples of binary classification problems. Now, let's talk about logistic regression to solve classification problem. Binary classification is mostly used or widely used in real life, and logistic regression is a good way to solve binary classification. Binary classification is usually have two classes, 0 and 1. So taking example of binary classification, let's walk through a logistic regression example. Here, what we see in the picture is x-axis and y-axis. X-axis represent a continuous value and y-axis represent the probability of that continuous value belonging to a class, which is a category. So it is classifying or categorizing a continuous value into a category. It belongs to category or no, right? So if it belongs to category, then the particular will see the orange dot for that particular value, and if it does not belong to category, we'll see a blue dot for that category for that particular value. So to right way to solve this problem is not about using a linear regression because it is not good. It does not fit the data well. So we cannot use losses. We cannot use a linear regression to solve to plot this kind of graph. We need some kind of a function that has a property of binary classification that can categorize the data into two classes. So this picture represents a function we would like to have that categorizes the data into two buckets and plot them in a seamless manner. This kind of function is called sigmoid function, and it takes any value and outputs a value between 0 and 1. So what we can do is that what we can what we can do is that we can take the linear function, linear model, and use that linear model to plot into the sigmoid function, which will in turn produce a S-shaped curve that will classify a value into 0 or 1. When we do that, it would look something like this. And using this graph, we can classify whether a particular point belongs to a class or no. For convenience, we can use 0.5 as a threshold. If anything is above, if any value that have higher probability or higher value than 0.5 in y-axis, then we can say that it belongs to a class. And if it below 0.5, then we can say that it doesn't belong to a class. In this way, we can classify a point using a sigmoid function, which is called logistic regression.